All right, im3 peeps. We're going to do a couple of these problems. I'm going to work them out, and hopefully it gives you a little more direction. This should all be reviewed from im2, the Pythagorean theorem. Let's try number one first. So the way I would do it is you always want to label your sides. So across from the 90 would be my C value. And then these other two sides here, it doesn't matter which one you label A or B. So this guy could be A, or this guy could be A. But these are the legs, so the legs could be A or B. So we'll just do A here, B here. All right, and then we're going to solve for x. So we're going to plug it into Pythagorean theorem, which says a squared plus b squared equals c squared. So we have a squared, which is 12 squared, plus b squared, which is 5 squared, equals c squared, which is x squared. Now let's just do the math here. 12 to the second power, it's 144, plus 25 to the second power, that's 25, all equal to x squared. And now we're going to solve for x. So we got to add these two guys. That gives me 169 equals to x squared. And to solve for x, we square root both sides. Okay, this is actually a perfect square. So x is going to equal 13. All right, and that's how you do Pythagorean theorem. Pretty simple. Let's go ahead and try number 3. Again, across from the 90 is your hypotenuse. That's your C value. And then we'll label this one A and this one B. So let's plug it into Pythagorean theorem. So it's a squared plus b squared equals c squared. A is 5 squared. B is 10.3 squared. And equals c squared, which is x squared. So let's do this math. We're going to throw this in our calculator. So 5 squared is 25. 10.3 squared is 106.09. And it's equal to x squared. And now we're going to add these two guys together. It gives us 131.09 equal to x squared. And again, to solve for x, we square root both sides. And x is going to equal, and we round to the nearest tenth, 11.4. All right, let's go ahead and let's do number 5. If you look at the directions for number 5, we are going to find the missing side again, but we're going to now not round to the nearest tenth. We're going to simplify the radical. So this is a little bit more review that we have to understand. So let's set this up really quick. Across from the 90 is our C value, our hypotenuse, and then we will call this A and this B. All right, so we're going to go A squared plus B squared equals C squared. That's going to give me 9 squared plus x squared equals 11 squared. And now let's do the math. So we're going to get 81 plus x squared equals 121 squared. I'm sorry, 121. And now let's solve for x squared. So in this case, our x value is no longer in the C value. So we have to solve for x by moving the 81 to the other side of the equation. So we're going to subtract 81. And we're left with x squared equals to 40. And now we're going to square root both sides to get rid of the power of 2. And now we have x is equal to the square root of 40. All right, let's do the work over here. So again, x equals a square root of 40, but we want to simplify the radical and leave it in radical form. So we do not want to throw this in our calculator. If you recall, this is the tree method. What multiplies the 40? First thing that comes to mind is 4 times 10 for me. And then we're going to break down the 4. That's 2 times 2. And then break down the 10 is 5 times 2. And so we now want to ignore all the things with branches underneath them. Or in other words, we want the lowest factors at the bottom. So these guys that do not have lines underneath them, these are the only ones we can choose from. So in other words, we want to ignore the ones with branches. Of the numbers you have available, we want pairs or groups of 2. So I have a group of 2. Every group you have will escape the radical. So this group of 2 will come out of the radical, but only one of them gets to come out. So it's going to look like this. So now we have outside the radical is a 2, which is represented by this group of 2. And inside the radical, because these guys don't have a group of 2, there's a single 5 and a single 2. They get multiplied and they get stuck in the radical. So we just go 5 times 2, and that gives me 10. So this is the simplified form. All right, let's shoot for number 7 real quick. Again, I'm going to label. This is my C. We'll call this my A and this my B. So it's going to be 9 squared, which is A squared, plus B squared, which is X squared, equals 16 squared. And now let's do the math. 9 squared is 81, plus X squared equals to 256. Subtract 81 from both sides because we want to solve for X squared. And we get 175. So X squared equals 175. And now we want to square root both sides. And X is equal to the square root of 175. And now we want to break this 175 down. So we're trying to figure out what two things can multiply to 175. And the first thing that comes into my head is 25 times 7. So 25 times 7. And now we break down these if we can. And we can break down 25 into 5 times 5. But 7 cannot break down, so we leave it as is. Now we're going to ignore anything that has branches underneath it. So ignore that guy and that guy. And now we're looking for groups of 2. We have a group of 2 of 5s here. So anytime we have a group, that one of those guys come out of the radical. Non-group members, like 7 here, does not have a partner. He has to stay in the radical. And this is simplified radical form. So number 9, we have to state if these 3 sides make a right triangle. So in other words, we're trying to check. Remember, the longest side will be across from the 90 if it is a right. And then we would do something like this. And all we're going to do is plug it into A squared plus B squared equals C squared. With the fact that your C is always your longest side. So 15 has to go in for the C in this case. So we're going to go 9 squared plus 12 squared equals 15 squared. And we simply do the math on this side, do the math on this side, and see if they equal each other. If they are equal, then it's a right triangle. So 9 squared is 81. 12 squared is 144. and 15 squared is 225. Let's add these two to see if it equals 225. So 81 plus 144, that is 225, and that is equal to 225. So this is a right triangle. Yes, it is a right triangle. All right, real quick on number 11, the square root of 14 would be your C value. So this is your A, B, and C, because square root of 14 is actually the longest side of all these. So we'll go 2 squared plus square root of 9 squared equals square root of 14 squared. And then let's do the math. So it's 4 plus, but you have to remember, square roots and powers 2 cancel out. So you're just left with 9 equal to 14. 4 plus 9 is actually 13, and 13 is not equal to 14. So this is a no. All right, let's do one of these down here. Okay, so we have to decide if it's acute, obtuse, or right. So when we're doing this, checking if it's acute, obtuse, or right, our key is we have to look at the C squared. If the C squared is bigger, then we have obtuse. If the C squared is smaller, then you have acute. And if the C squared is equal, then you have a right. So it's all about the C squared. So let's try number 12. So here's my C. We'll put this as my A and B. So let's plug it into A squared plus B squared equals C squared. So A squared plus B squared equals C squared. Okay. Again, I said equals, but we're really checking here. We'll put like a little question mark because we don't know if it's equals. All right. So let's do this math up here. 8 to the second is 64 plus 36. Now we want to know if it's equal to 100 or less than 100 and so on. So 64 plus 36, that is actually 100. Bring down this 100 and they are equal, which makes it a right triangle. Okay, let's do 14. So again, your C will be your longest side. So this will be my C. We'll call this guy my A and my B. So A squared plus B squared, and then we are checking, is it equal, bigger, smaller than C squared? So let's do the math. 3 squared is 9, 12 squared is 144, and then C squared, I forgot to plug it in, is actually 13 squared is 169. Okay, add this up. This is going to give me 153. This is 169. Again, we want to focus on the C squared. Is the C squared bigger, smaller, or equal? And the C squared is bigger. Therefore, we have an obtuse triangle. Hopefully that helps. Have a good one.